Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, welcome to the next lecture of CS103 Computer Programming. In this lecture, I'm going to be talking about control structures 2, which is repetition. In the previous lectures, we have talked about something about the evolution of programming languages, a few things about basics of a C++ program, a few things about input and output and how to handle file handling and input from the standard input device. We have talked a bit about something about the control statements in the control structures, in which I basically talked about the switch statement and the if-else and else-if conditional statements. So in this particular lecture, we'll now talk about something which is called repetition or loops as in general terms. So let us now formally begin chapter 5. The chapter is all about repetition, and what we tend to learn in this particular chapter is that we want to learn about repetition or looping control structures. We want to learn how to use a while loop in a program. We want to explore, so while loop is a typical loop which is kind of common in a lot of other languages as well as C++. We want to explore how to construct and use counter-controlled, sentinel-controlled, flag-controlled, and end-of-file controlled repetition structures. We want to learn how to use a for loop in a program. We want to learn how to use a do-while loop in a program. We want to examine the break statement and continue statement and how do they affect a looping structure, for or while, whatever. We want to discover how to form and use nested control structures. We want to learn how to avoid bugs by avoiding patches. And then we want to learn how to debug loops. So with that, let's begin the program. Why is repetition really needed really? Because a lot of times it's the same code that is going to be run on a different set of variables, and we can have a certain pattern. So for example, if you want to input a number of different variables, if you want to add a number of variables, if you want to get an average multiple number of variables using a limited set of variables, in that case, you can always use repetition to do all these options in a very concise and brief code. Although you can do it even without using repetition, but you will see that that code will be really, really long. So for example, if you want to add 5 numbers, the easiest way that you can do is that you can declare a variable for each number, input the numbers, and add the numbers together. That is one way you can do it. So for each number, you are going to ask for input and then ask for, then add them together to the previous one and then go on to the next one and so on. The other way is that create a loop that reads a number into a variable, adds it to a variable that contains the sum of the numbers, and loop over it for the next number, add it to the variable, loop, loop, loop. It will be small code, concise code, easy to understand, and does the job exactly as intended. So here you can see the difference between two approaches. This one you need to write again and again and again. You might write an incorrect variable name or something, and then the result is going to be messy because this is a longer code, relatively a piece of code that is hard to read and hard to understand as well for the reader. This one is going to be straightforward, concise, brief, to the point, and does the job exactly as intended as would the other method do. So no difference here. The syntax of the while statement is very simple. You basically have a while followed by an expression. This is also a condition based on if this is true, only then these statements will be executed. The statement can be a simple statement or a compound statement consisting of multiple statements. Expression will act as a decision maker whether to run the while loop or not. It is most in most cases it is a logical expression. However, it can basically be a simple logical statement as well, like true or false, whatever it is. But that's generally not true. The statement here is what we call the body of the loop. And the parentheses that are going to be placed here are part of the syntax. So these parentheses are supposed to be here for each expression. You cannot write a while loop in C++ without putting in these braces, and these parentheses are hence part of the syntax. So if we go to the flowchart diagram of a typical loop, this is how it looks. And this is what I showed you in the when I was introducing control structures to you in the previous lecture as well. You start from this point, you go to the expression, you check if this is true or false. If this is false, you just simply move out of this loop. Otherwise, if this is true, you execute the statement, go back, check the expression again. If true, execute the statement and move back and continue on with this. So now you may be confused that, if the expression is true once, it will remain true, because once the statements are executed, it will again go back, again check and check and check and check. And since this expression is once true, for example, 5 is less than 10, it is true. The statement will be executed. It will be executed all the time because 5 is always less than true. The answer is that you need to put in a statement, an expression that is always changing, and we'll see how that is done in the next slides. So for example, consider the following C++ program segment. Assume that I is an int variable. So I is an int. It is initially initialized to 0, while I is less than equal to 20. So here you see that while 0 is less than equal to 20 is true for now, but we'll see in the program that it will change. And once this changes, the value of I changes, the condition in the while will keep on changing as well. So that's the beauty of this particular using a variable in this condition. So since 0 is less than equal to 20, we're going to execute cout 0 space. Here we increment the value of I. So initially I was 0, so I now is 5. 5 is still less than equal to 20, so now we output 5. Now I then becomes 5 plus 5, 10. So I is now 10. 10 is still less than equal to 20, output 10. Then I becomes 15. 15 is less than equal to 20, output 15. Then I becomes 20. 20 is still less than equal to 20, so we output 20. But now I becomes 25. 25 is not less than equal to 20, so we move on to the next one, move to the next line, and here's the result now. If we run it once, we'll have 0, 5, 10, 15, 20, and then we move on to the next line, right? So that's how this is being executed. Let's go to the next line. The variable I in example 5.1 is basically called the loop control variable. It controls the loop. And you might enter a thing which is called infinite loop, which is that we continue to execute endlessly. And this is actually avoided by including statements in loop body that assure the exit condition is eventually false, like we did in this case with I using a loop control variable. And the loop control variable basically ensures that we do not get stuck in an infinite loop. We need to always avoid this infinite loop, because otherwise the program will continue to run endlessly and will never stop. And we want the program to stop at some point. The repetition needs to stop at some point. So here's another example. In this case, I is less than 20. We start with I is equal to 20. I is less than 20. And in case I is less than 20, we'll output these statements. Otherwise, we're going to stop here. But here's the problem. Since I is equal to 20 is not less than 20 is not less than 20. Hence, this is not true. If this is not true, we'll directly move to the next line. And it is very easy to have a condition that is never met, actually that's already false at the preset of the program. And if that is true, we're never going to execute this while loop, right? So to enter this loop, you must have a true condition at least once. However, you're changing the condition inside, and then as you change condition, you might want to get out of the loop at a certain point, and hence this is very useful. So this condition needs to be true at the outset. If you want to run the while loop, it needs to be false if you don't want to run the while loop at all. Sometimes that is necessary. At other times, it's an unwanted consequence of your declaration of the value I, whatever that is. Okay, so let's talk about something which is called a counter-controlled while loop. So when you know exactly how many times you are going to run the statement, or you want the statement to be executed, you can use a counter-controlled while loop. What is the counter-controlled while loop? Well, you initialize the loop counter variable by the name counter by 0. While the counter is less than a certain n, the number of times you want to run your statements, right? Just increment the counter once, and this is going to execute exactly n times. Now we know that this is going to be executed, starts with 0, goes on till n minus 1, and when it gets equal to n, it's going to break out. So this is going to be executed exactly n times. This is what we call counter control statements. The other type of example is what we call Sentinel controlled while loops. What are Sentinel controlled while loops? Sentinel variable is tested in the condition. So Sentinel is basically a character or something that you set as if when the value is equal to this particular number, we are going to break the loop. We are not going to execute after that value has been met. But until that value has been seen, we'll continue to run the loop. So for example, we ask the user to enter a variable first. If that variable is not the Sentinel value, not the quit value, we ask the user somewhere in the program to input the variable again. If that value is not equal to Sentinel, we'll continue to execute the whole thing again, asking for the user for a variable each time so that whenever he wants to quit, he just enters the Sentinel value and the program will halt at that position, or basically the loop is going to halt at that position and we're going to get out of the loop. So example 5.5 in the book basically provides an example of a Sentinel control loop. The program converts uppercase letters to their corresponding telephone digits. And we'll see that example in when I talk about the program at the end of the lecture, the code at the end of the lecture. So we need to wait till that time. Okay. Similarly, flag controlled while loops is basically when you use a Boolean value to control the loop. So until you don't find a particular value, you keep on looking or searching for the next things. And as soon as a certain condition becomes true, you set the flag to the opposite value, to the false value. And once the flag is false, you basically quit the loop. So in this case, it's basically not found. The value of found has to be false throughout. So when this expression becomes true, the found becomes true. And once found is true, the negative of found is false now. And if this is false, once this gets executed, in the next time, we're not going to run the while loop, we're going to stop at that particular place. So this is what we call a Boolean or a flag control. This found is our flag. Until this is true, we're going to run it. As soon as this becomes false, this particular not found statement becomes false, we're going to stop executing the loop. And in this case, we now have a number guessing game at example 5.6, which implements a number guessing game using a flag controlled while loop. It uses the function rand of the header file cstdlib to generate a random number. So the function random, as you might be using in your projects pretty much soon, is basically given in the file cstdlib, which is a random file which generates a random number, an integer value between 0 and 32767. If you want to convert it to an integer which is greater than equal to 0, which is within a certain range of, let's say, 0 and 100, you just need to take a mod of 100. So with the mod 100, the value will be between 0 and 100, not including 100, of course. So 0 and 99 will be the values, and that's how you can convert a random number into a corresponding integer between, let's say, 0 and 100. The random function returns an int value, which is a random value between 0 and 32767. And you have kind of studied it a bit in your discrete structures course. Another type of while loop, or how you control while loop, is where you can basically use an end of file to basically exit your while loop. So EOF, end of file while controlled while loop, is always used when it is difficult to select a Sentinel value, when you don't have a specific Sentinel value. And in that case, the logical value returned by cin can determine if there is no more input. So you need to put cin in the while loop. If cin returns a false value, you basically say that there's no more input anymore. So for example, here's the case: cin number, while cin, whatever that is, sum is equal to sum plus num. Cin is greater than cin display num. So you get num here, and that is what's being updated each time. So this number is being updated. You just input cin here. Cin is basically the input from the input stream, and in the input stream, whenever you encounter a false or basically 0, you're going to quit. So if you look at this particular program, This will keep on executing until you're getting numbers that are not zero. And as we know, numbers that are not zero are all true. So this one is going to be all true for everything else other than the exact number zero, where this is going to be false for sure, right? So with that, let's move on to the next example. And we'll see these in the at the end of the lecture as well in a lot more detail. The function end of file can determine the end of file status. So there's a function which is called EOF. EOF stands for end of file, and this returns end of file status. From input stream, you can basically use the function EOF using the particular syntax that is given here to determine um, this particular iStream variable.eof. So it's cin.eof, or you can use some other variables. And this function is very useful to determine when you basically the file has ended. So for example, iStream variable in this case can be anything, any input stream variable. For example, it can be even cin or a file opened that we saw earlier. So that's kind of about it about the end of file function. We'll see some examples maybe at the end of the lecture. So let's go on to some more examples on expressions in while statements. The typical expression in while statement can also be complex. They can be simple, they can be complex. It's not necessary that they are of a certain type. For example, this one is number of guesses less than 5. And then the number has not been guessed yet, so we keep on continuing to execute this while loop until either the number of guesses exceeds 5 or the number gets guessed. But the thing here, the common thing or the common thread here between all these statements is that they return exactly one logical value. They're either true or false at any time. And you can use end of files sentinels or sentinel values or anything that you need to use a direct statement or whatever, but this needs to return true at certain times and become false during the execution. If it does not become false, then we'll be stuck in an infinite loop. If this becomes false, then we can break out. Of course, there's another way. It need not necessarily be true all the time, become false somewhere during the run, because we can use the break statement to quit, and we'll see that in a few minutes actually, how the break statement can be used to quit an ever true statement in here, an ever true condition. So for example, let's say you want to compute the Fibonacci series and the Fibonacci numbers. So let's say we have a series of numbers which is basically 1 1 2 3 5 8. These are called the Fibonacci sequence because you sum the first two digits are 1, you sum them up, you get 2. You sum the next two up, you get the sum 3. Sum these two up, you get the next number 5. You sum these two up, you get the next number 8. Sum them up, you get 13. Sum them up, you get 21. Sum them up, you get 34. Sum them up, the next number is going to be 55, and so on. So this is what we call the Fibonacci sequence. Given the two numbers, the first two numbers of the sequence, whatever the first two numbers you get, a1 and a2, the nth number an, which is n is greater than or equal to 3 of this sequence, is given by an is equal to an minus 1 plus an minus 2. So the sum of the two preceding numbers. So you can get any two numbers and we can basically compute the Fibonacci sequence beyond that particular point. The Fibonacci sequence typically computes of the nth Fibonacci number. We start with a2 is equal to 1 and a1 is equal to 1, and we want to determine the nth number an, where n is greater than or equal to 3 for sure. So suppose that a user enters a2 is equal to 6 and a1 is equal to 3. In that case, a3 is going to be a2 plus a1, which is 6 plus 3 is equal to 9. A4 is going to be a3 plus a2, which is 9 plus 6, which is 15. So we want to now write a program that determines the nth Fibonacci number given the first two numbers. So you're given first two numbers and we want to write the nth Fibonacci number. The input to this case is going to be the two Fibonacci numbers that are going to be desired to that are basically the starting point of the Fibonacci sequence, and then we want to basically also take as input the desired Fibonacci number. So if you want the 5th or the 10th or the 12th Fibonacci number, you just need to enter 10 or 5th or 12, whatever that is, as your desired Fibonacci number. Output is going to be the nth Fibonacci number. The the number, the Fibonacci number that comes in the sequence at that particular position, 5th position, 10th position, or 12th position. So let's come up with the algorithm first. How are you going to design this particular problem? Well, the idea is, of course, you need to get the input from the user. So from the user, what you get is basically the first two Fibonacci numbers and the position n of the number in the sequence. Then we need to compute our Fibonacci series. So from the first, you compute the first and second, you compute the third one, right? So the third one is simple. You just add the previous two elements of the sequence to calculate the next Fibonacci number, and you need to repeat this step all throughout until you basically reach the nth Fibonacci number. Upon reaching the nth Fibonacci number, you need to break out and output the nth Fibonacci number itself. So that program is actually given at the end, but here just the algorithm is mentioned. I'll kind of discuss it at the end of the lecture about how you're going to use the while statement over here, and how you're going to use to build up a program for the Fibonacci sequence. So let's see a programming example here. What we given is basically some integer variables that are declared as previous one, previous two, current, and counter, and nth Fibonacci. We'll prompt the user for the first two numbers, that is previous one and previous two. So we get the first two numbers from the user. We then read the input into the previous one and previous two. We then output the first two Fibonacci numbers. We then prompt the user for the position of the desired Fibonacci number. We read the position of the desired Fibonacci number into the nth Fibonacci. So if nth Fibonacci is equal to 1, we already know the first one. So we copy the value of previous one into the current. Otherwise, if the nth Fibonacci is 2, we again know the second desired number, right? So we copy the value of previous 2 into the current. Otherwise, if it is neither the first one nor the second one, then we need to calculate it for the third one and onwards, right? So then we calculate the desired Fibonacci number by using the following sub algorithm or module. We start by determining the third Fibonacci number, right? So we initialize counter to 3 to keep track of the calculated Fibonacci series. We calculate the next Fibonacci number as using the following. So previous 2 plus previous 1 is going to be a current. Then we're going to assign the value of previous 2 to previous 1. So we shifted 1, we assign the value of current to previous 2, shift the current into the previous 2, we increment the counter by 1, and we repeat until the Fibonacci number is calculated. So here is the main algorithm here. While counter is less than equal to nth Fibonacci, we increment the current to basically previous 2 plus previous 1. We set previous 1 to previous 2. We set previous 2 to current, and we then increment the counter. And again, once the counter is incremented, if it is still less than equal to nth Fibonacci, we keep on moving ahead in the current value, previous 1, previous 2, and counter. Once we actually the counter increment is greater than nth Fibonacci, we're going to break, and at that time the current value will be what is supposed to be your nth Fibonacci value. So yeah, finally we output the nth Fibonacci number, which is basically the current value, and we are done with the program. We'll see the program in more detail with execution at the end of the lecture. At the moment, we'll move on to the nth Fibonacci number, to the for loop, which is basically another repetition structure. It is called a counted or indexed for loop. The syntax for loop is very simple. We have got an initial statement, the initializing statement, the declaration. We've got a loop condition, which is going to check if we want to loop anymore or not. And then we've got an update statement. If we actually want to run this, we'll then execute the update statement every time, except for the first time. And then finally, the statements are going to be executed based on if the for loop is running or not. If it's not running, do not execute the statements at all. So the initial statement, the loop condition, and update statements are all called for loop control statements. Each of these is what controls your for loop, and hence each of these is what is called the for loop control statements. While this one is the statement that is going to be running at the end of the program, or basically every time the for loop is being executed, at the end of these three, this will always be running. And we'll discuss the order of these three as well. So when is this statement called, for example, when is this statement called, when is this statement called? So From a control flow diagram, a flow chart diagram, what we observe is we start with an initial statement, right? We check if the loop condition is met. So this is the initial set of the first statement among the for loop control statement that is going to be run is the initial statement. It is first initializing all the variables. So everything that you want to initialize is being initialized in this statement. You initialize them, then you move on to the loop condition. The loop condition is then the second condition that is being executed. If this is false, we simply move on to outside the loop and get out. Do not execute this statement at all. So if the loop condition is false, we don't execute anything and move out. If the loop condition is true, then we execute the statement. And after executing the statement, this statement, we then execute the update statement, which is basically this statement. So the order here is execute this, check this, execute the statement, execute the update statement, and then move back to the loop condition again. Check again, statement again, update statement. Loop condition, statement, update statement. Loop condition, statement, update statement, and so on until basically the loop condition is false, at which point we're going to exit the for loop altogether. And this statement again can be compound statement. It's not necessary a single statement. But so this is the order of the for loop control statements. And here is a small example of a for loop which prints the first 10 non-negative integers. So we initialize, we start with I is equal to 0. While I is less than 10, we execute increment I. And in that case, we output the I values throughout. And since this is a single statement without braces, so this will be executed within the for loop, but this one is outside the for loop. So you need to understand that once you increment I continuously and the value of I reaches the value 10, then in that case, this condition is false. And once this condition is false, we're going to stop the for loop and go out into the endl and the rest of the program. So let's take another example that outputs hello and a star on separate lines 5 times. So it needs to put output hello, then followed by a star and so on. If you execute it, this is going to start from 1. Since we know it's going to be executed 5 times, so 1 is less than equal to 5, execute hello star, then increment value of I to 2. Again check 2 is less than equal to 5, again execute them, again increment, again check, increment until the value of I becomes 6. By this increment, once it becomes 6, then when you check the value, this is false and we need to break the loop. So let's check for this particular example, the following for loop. This loop will only output hello 5 times because this does not contain braces and this is not going to execute, this is not considered a compound statement. So it consists of only a single statement, and it will not print this hello, it will print this hello 5 times, and then finally when it breaks the loop, it will then print star. So star is going to be printed only once at the end of the program, but hello will be printed 5 times consecutively at the start of the for loop. Then here's an example that is basically a semantic error here. So in this case, what you're trying to do is you start with I is equal to 0. While I is less than 5, you increment it by 1 and you output static and you basically end. So in this case, what we notice is that if you put a semicolon at the end of a for loop, it is going to be taken up as you want to run a for loop, but you don't want to actually perform any statement within it. So there's nothing that is going to be executed. Putting a semicolon at the end of a for loop is a semantic error. You should avoid that. That is one of the most common reasons you are going to come up to me in your class or maybe in your labs and say that, okay, this for loop looks absolutely fine. Why is it not executing anything? And that is because you by default you believe that putting up a semicolon at the end of every line is necessary. So putting up a semicolon at the end of for loop is going to mess up your program altogether. And this means the for loop is going to now be executed 5 times for empty statements only. So if you look at the other extreme where you do not do anything, no condition, nothing else in here, this is allowed, this is legal, because actually you can break using the break statement somewhere, wherever you want. But this is basically going to be, this may be an infinite loop as well. So in this case, this is an infinite loop. This is an allowed one, this is a legal one, but you should try to avoid it for most of the times, because this one is going to be running infinitely, at least up till this portion. If it's just contains this statement, then this runs infinitely. You can also use counting. You can also use for loops for counting backwards if the for loop control expressions are set correctly. So in this case, we're going to count from 10 to 1 and stop at 1, basically by using the decrement operator here. So this update operator can increment or decrement depending on what you want. And this is what it does. It basically outputs the value 10, 9, 8, 7, 6, 5. So it does the backward counting. Notice that in this particular for loop, the variable I is initialized to 10. After each iteration where you are outputting these values, you're decrementing it, and then you're basically checking for the condition again. And it continues until the condition is met. As soon as the condition is broken, you basically exit the for loop. Then there's another example where you can increment or decrement the loop control variable by any fixed number. So instead of just decrementing by 1 or 2, actually you can decrement it by 2 or increment it by 2 to reach a certain values, or put a certain jump in numbers. In this case, once you use this particular structure, it's going to output 1, 3, 5, 7 until 19. Once the value becomes 21, this condition is not met and we're going to break out. But until then, we're going to run it exactly 10 times to output 10 positive odd integers between 1 and 19. Okay, so this brings us to another kind of a looping structure, which we call the do-while loop. The syntax of a do-while loop is slightly different from a while loop. Here we have got a do followed by the compound statements or a simple statement followed by a while expression. The statement is executed first at least once, and then the expression is evaluated. So the difference between a while loop and a do-while loop is that in a while loop, the expression is checked first and the statement is then executed. In a do-while loop, the statement is first executed and the while loop is checked. The condition in the while loop is checked after executing the initial set of statements. So as long as then the expression is true, the loop will continue. Otherwise, the loop is going to break after that. So, but to avoid an infinite loop, the body must contain a statement that changes the expression throughout and ultimately makes it false. A do-while loop is basically, or the statement in a do-while loop can basically be simple or compound, as I said earlier. And the loop will iterate at least once, but it can, of course, loop up to infinite times as well. If the condition does not become false at any stage, we keep on looping for infinite times. So here is the flowchart diagram of a do-while loop. In this case, you execute the statement first, you check the expression. If it is true, you then again execute the statement and continue with the expression in this cycle. Once the expression becomes false, you actually move on to the next line. So notice that the statement will be executed at least once, but it can be executed more times again if the expression remains true. So for example, let's say I is equal to 0. In this case, we start with the do while loop. So we first execute output the value of I, which is 0. Then we increment the value by 5. And then we check if the value is less than equal to 20 or not. If it is not, we break. If it is, we again continue on with the loop. And the output of this code is again 0, 5, 10, 15, 20. After 20 is output, the value then becomes 25. The value of I becomes 25. And hence at 25, the condition becomes false. And this is where the loop is going to halt. Okay, so here's another example of the do while loop. In this case, we initialize I with 11. While I is less than equal to 10, which it never happens actually, we output I is equal to I plus 5, and we end. So in this case, since 11 is already greater than 10, we're never going to run this program even once. However, in this do while loop, we notice that we initialize I by 11. We have a do, so we always execute the value cout 11. 11, we increment 5 into 11, so now it becomes 16. And since 16 is not less than equal to 10, it is always greater than 16 is greater than 10. Hence, this is false, and we move out. But in this case, we do get one output, which is the value 11, before we finally exit the program and say that the value is greater than 10. We don't need to execute it. So this is executed at least once. This is going to be this can be executed 0 or more times, and this can be executed 1 or more times. For you need to identify which loop to use and when to use that loop. For all three loops in C++ are equally useful, and they have their place in C++. If you can determine in advance the number of repetitions needed, of course, the for loop is a correct choice.
If you do not know and cannot determine in advance the number of repetitions needed, and it could be 0 as well, then you could use a for loop. So we, in case you don't know um, how many times you want to run the code, a while loop is always useful. If you know exactly how many times a loop is going to be running, you can use the for loop. And a while loop is useful when the code can be ran 0 times. If you do not know and cannot determine in advance as well the number of repetitions needed, and the number of times it is needed to be run is at least once, then use a do while loop. So like I said before, a while loop can be run 0 or more times. A do while loop can run 1 or more times. And hence, if you know that the program needs to be running at least once, then you're going to be using the do while loop. Then another important aspect, yeah, one more thing. So actually, wherever you want to use a do while loop or a while loop, you can equally use a for loop with some modifications. So it's not necessary that if a person fits in uh, let's say a for loop, and his friend or her friend actually fits in a while loop in that place, that is very much possible. Both while and for are interconvertible and can be used together. It's just that in some cases it's more clear, or it's more observable to use a for loop. So wherever you have in advance number of repetitions, always go for a for loop. If you do not know in advance the number of repetitions, then you should always go for a while loop. But I mean, over the time, I've noticed that one becomes comfortable with with the particular looping structure, for example, the for loop or the while loop, and then it becomes impossible to go back. So break and continue statement will is what is the next topic. And the break and continue statements actually alter the flow of control. We have already observed the break statement in the switch structure. One of the uses of break statements is when you want to skip the remainder of a switch structure and actually move out of the switch structure, and this is what we used earlier. But another important usage of the break statement is to exit early from a loop. So if you want to break a loop, if you want to get uh, if you want to exit or eliminate the current loop, you can basically use a certain flag variable, and by using that you can basically exit from the loop early on and apply the break statement. So after the break statement is executed, the program will continue on with the first statement after the structure. It will quit the structure, and whatever statement comes after the structure, it will start executing that, be it the for loop, while loop, or the do while loop. If you exit it using the break statement, you move on to the next statement right after the loop. On the other hand, continue is slightly different. It is used inside the while loop, for loop, and do while structures again. However, the continue statement cannot be used in a normal program otherwise. What continue does is that it basically goes back to the last looping point without executing the rest of the statements. So it just skips the remaining statements and proceeds with the next iteration of the loop. Just increment it again, check the value, again continue on with the rest of the execution, except that the statements that were after this particular continue statement will not be executed. Then there's another very important example of nested control structures. So for example, here's a program that draws up 5 stars, each in a way that the first line contains only 1 star, the second line contains 2 stars, 3 stars. This looks more like a 2D matrix, right? So this is a 2D thing that's going on. On one side, you're incrementing the rows. On the other side, you're incrementing the number of stars on each row. And this can be simply accomplished by using the nested control structure, the nested for loop in this particular case. So for example, we know that we need to start from 1 and go until 5. So starting initialization is 1, go until 5, and you increment I as you go along. For each of these, you start with j is equal to 1. And here the condition is while j is less than equal to I. So in the first run, it is j is less than equal to 1. It will run once. In the second run, it's j is less than equal to 2. It is going to run 2 times. In the third run, it's going to run 3 times, 4 times. And this is the exact point we're just outputting the value star here. And then you, after outputting the number of stars, you actually enter the next line. So In the first time you run, you output 1 star, you output the next line, and you move on to I is equal to 2. In that case, you can run it twice. You're going to output 2 stars, and then finally you're going to exit this for loop, come to this C out statement, execute it, and you're basically going to get your program printed out in these the printing out these stars actually. So what is the result if you replace the first for statement with this one? I is equal to 5, I is greater than equal to 1, I minus minus. So the first for statement is I is equal to 5, I is less than I is greater than equal to 1, I plus I minus minus. So this is going to do it in the exact inverse. It starts with 5. So the first value here is 5. So while j is less than equal to 5, we're going to execute this for loop. So this is executed 5 times, finally followed by this one. The next time it's going to be running 4 times, 3 times, 2 times, 1 time, and hence you observe the exact opposite pattern of the stars. Um, so what is a software patch? A software patch is a piece of code that is written on top of an existing piece of code. And generally a software patch is always written to fix a bug in the original code. For example, a lot of times in the early years, we always used to have what is called the Windows patches for Windows operating system. They were intended to fix a bug in the original code that were present there. And what some programmers typically do, and that was what was done in the earlier operating systems as well, was that some programmers addressed the symptom of the problem by adding a software patch. So that software patch would instead resolve the underlying issue, and hence whatever is the cause of that particular bug would be removed. So however, there's one thing, generally you need to avoid bugs by using the avoiding patches. Whenever you used to have a patch installed for your program, it would introduce more errors into it, because underlying issue would not be the symptom of the problem would not be solved, the original logical error would not be caught. However, you masked it by using the patch, and that mask would also have its own side effects. You have not actually fixed the problem, you have not solved the issue, however you have masked it out. And by masking it at certain other variables, your mask can basically also cover some valid cases as well. And so by putting in patches, you are actually introducing more bugs into your program. So the shortcut, or the short software practice, a good software practice, a good programming practice would be to avoid bugs simply by avoiding patches, but instead finding the correct logical or semantic error and then fixing that error, instead of putting in a patch on top of your program to mask a problem, which is not working most of the time. We'll see those examples again at the end maybe. So how do you debug loops? The problem is that when you're running a sequence of selection structure, it is very easy to debug them because they run exactly the same number of times. They start from the top, they are running in a sequence, they are either executed or not executed. If you enter a selection structure or you don't enter a selection structure, doesn't matter, because if you're not entering a selection structure, you'll observe that by using a simple cout command, you can observe that you did not enter the selection structure. Similarly, if you're running something in sequence, a simple cout command helps out. However, loops are a bit different. It's hard to debug them. And as compared to, of course, selection structures and sequence structures, it's not impossible, but it's harder. You need to use some invariant of the loop. So for example, the set of statements that remain true each time the loop body is executed. And by using loop invariants, you can actually check if how many times the loop is actually running and what's the values of your variables each time. So the most common error associated with loops is off by 1, and off by 1 basically means that loops always start from 0 or 1, and you're always off by a value of 1, and that's where you need to control things. And we'll discuss, I think, again, this off by 1 error. Off by 1 basically simply means that, for example, you have to start from 0, but you start from 1, or you start from 1 and you basically end at less than the number of times it is supposed to run. At other times, you end it by you start from 0, and you're actually supposed to end it by n minus 1 and not n then. And however, you actually run it to n, so you're off by 1 again. You're going one extra iteration.
And that is one of the most common error that occurs within loops. So you need to have the exact value running exactly the same number of times. If you start from 0, you need to run till n minus 1 to run it n times. If you start at 1, you need to run it till n to run it n times. And if you do otherwise, so start from 0 and run it n times, you're going to be running basically n plus 1 times in total. However, if you start at 1 and then run till n minus 1, then you're running n minus 1 times in total, again off by 1. So you can either be n plus 1 or n minus 1, and this is what happens common in loops, and this is what we call the off by 1 error. So to summarize my whole talk, my whole lecture here, C++ has 3 looping or repetition structures: the while loop, the for loop, and the do while loop. The while loop, the for loop, and the do while loop are basically reserved words. So do, for, while are reserved. You cannot use them for naming your variables. The while and for loops are called the pretest loops. So both of these loops actually perform a pretest value before they execute the statements. If they're false, they will not execute it even once. So with while loop and with for loop, you can actually have statements that run 0 times. With the do while loop, however, that's something that basically first runs the statement once before testing the condition, and hence it's called a hence it's called a post test loop. And it will guarantee to run the statement at least once. So while and for loop may not execute at all, may execute actually 0 times, but do while loop always executes at least once. So it's slightly different, and hence it's called a post test loop. The while expression is the decision maker, and in a while loop, the expression is the decision maker that decides whether the statements in the body of the loop will be running or not. And statement is called the body of the loop itself. So a while loop can be counter controlled, that is controlled by a counter, a number. It can be sentinel controlled. Until you enter a certain sentinel value, it's going to be executed, or end of file controlled. For example, we saw cin in the examples. In the Windows console environment, the end of file marker is entered using Control Z. So in Windows, you need to enter Control and Z. In Mac, you need to enter Command Z for the same thing. Or at most of the times, since your environment will be set to Windows again, you can also use Control Z in Mac as well. But if you're on the command line or somewhere else, a Command Z might work instead. So basically, you need to know that a while loop can have the end of file controlled statement, and an end of file controlled marker is basically Control Z for a Windows console environment. If you talk about the for loop, then the for loop simplifies the writing of a counter controlled while loop. It's the same as a while loop, but in particular the counter controlled while loop, but it simplifies the writing of it. So it puts all the initialization, the condition checking, and the update operation in a single line. However, putting a semicolon at the end of the for loop is a semantic error and should be avoided. Basically, it means that an empty for loop is going to be running for the number of times, which is not really wanted 99.99% of the time. So it should be avoided most of the times until you exactly want it to be running for a empty for loop. And hence, do not put a semicolon at the end of the for loop or a while loop for that matter. It executes in a similar manner. Executing a break statement in the body of a loop will immediately terminate the loop. However, executing a continue statement in the body of the loop will skip to the next iteration instead. It won't break it, but it will directly move to the next iteration, skipping the next lines that are to be executed in the same iteration. So with that, this particular chapter comes to an end. I'll now move on to the examples, and we'll see some coding examples pretty soon.